screen.
Okay, great.
Okay.
So, microphone is not working. Alrighty. So welcome to this session. It's called Ifupdown2. We all know what Ifupdown is, so we're expecting some enhancements here on building on the existing infrastructure, and I'm happy to introduce to you now. You're going to say your name?
Roopa Prabhu.
Who comes to us from Cumulus Networks, and you're working on this.
Yes.
Because your employer is paying you. So please welcome, and let's have a good session.
Hello, everybody. I'm Roopa, and I work for Cumulus Networks, so I think I'll just start with the talk. The outline, a bit of background of who we are, because that sets the context for why we went into these why did we upgrade, develop Ifupdown2 and enhancements to Ifupdown2. A little bit of light into network interface configuration on network switches, and the challenges we faced, a little bit about Ifupdown, introduce Ifupdown2, a bit into the features of Ifupdown2, next steps, and questions after that. Background. Cumulus Linux is a Debian-based distribution for network switches. Our philosophy is manage your network switch as a server. We use the server distribution on a network switch. We have made some enhancements to some of the packages. And our philosophy is you use your existing tools to configure network switches. So your network switch ports appear as NIC ports on a server. And we basically use the Debian server environment to boot up the switch and manage network interfaces, etc. So current release of Cumulus is based on Debian VZ. And we started with Ifupdown, deploying Ifupdown on our switches, and we faced a few challenges, and hence the Ifupdown2. What kind of configuration we do on our switches? Usually there are a large number of interfaces. We have usually about 52 switch ports, and we configure a ton of bridges. Every VLAN is a bridge, and we have bonds and tons of VLAN devices. And the VLAN devices scale with the number of VLANs. So you can imagine we have thousands of VLANs and thousands of bridges. And large number of interface attributes as well. We have a bunch of network protocols that run on our box because it's a network switch. So, and every interface, every bridge interface, we run STP, MSTP, and so we have ton of attributes for STP, IGMP attributes that we need to be configured on interfaces. Mostly static configuration, unlike hypervisors or desktops. This is, So the challenges we faced with existing network interface management tools, this is mostly in context of Ifupdown, but in general we did a survey of other network interface management tools on Linux, and we did find that they didn't suit very well for our needs. So most of the network interface managers are optimized for desktop and hypervisor environments, mostly to environments where with dynamic interface configurations. And we've seen that complexity increases with the interface configuration scale. With large number of interfaces, the interface configuration becomes very complex. Large number of files, or the files get too large, and so on. In most cases, the dependency of network interface configuration ordering is on the user. User has to declare his interface configuration in a way that bonds that are members of bridge ports have to be created before the bridge, etc. And lack of support for incremental changes to network interfaces. This was particularly in context of Ifupdown. Ifupdown did not allow you to change an already existing interface or update configuration on an already existing interface. You had to bring down the interface and then bring it back up. And lack of tools to query and validate. So you apply a configuration with ifupdown, and then to query the applied state, you had to go back and look at the configuration using native Linux tools. For example, a bridge, you could create a bridge using ifupdown, but go back and look at it using brctl or iproute2, etc. This slide is basically just says the same things, but it also shows what are the benefits of ifupdown. It has a pluggable architecture, which is good. You can drop a script in for any new configuration that you want. Uses native Linux tools, enables faster development, and you don't have to duplicate whatever your native Linux tool does into your network manager. For example, today iproute2 is kind of becoming the only tool to manage all network interfaces or create network interfaces. So we use iproute2 a lot, and we believe that in the future iproute2 is going to have support for almost all types of interfaces. And ifupdown has good user documentation. It's a well-known tool. And most of our previous customers, first release customers, were already on ifupdown. So, and the challenges, most of them I spoke on the last slide. The other thing was development was also a challenge because ifupdown was written in a literate programming language. And we did face a few bugs with ifupdown. ifupdown2. ifupdown2 is basically re-implementation of ifupdown in Python. We chose Python because it's easier and faster development, and we could use existing modules and add functionality quicker. You will see in the next few slides. And it's backward compatible with ifupdown with the interfaces format and also with the names of commands. The commands, you'll still find the commands ifup, ifdown, ifquery, but you'll find them with newer options and there are a few missing, minor missing functionality like mapping and maybe other address families. It only supports inet and inet6 today, but that will be trivial to add in the future if needed. And it continues to use existing native Linux tools, pluggable architecture. ifupdown used bash scripts. This supports Python modules and meets some of the challenges that I described in the previous slides. Packages. I initially did it as 2 packages that could change in the future, but to keep things separate, I have them as 2 packages right now. So ifupdown2 contains the base infrastructure to parse, schedule, and order interface network interface configuration. ifupdown2 add-ons contains a bunch of Python modules, add-on modules. As you can see, there is a module to configure addresses, a module to configure DHCP, and bonds and ETH tool and MSTP, bridge, etc. This picture just shows the ifupdown2 package. That's the infrastructure package sitting at the top. ifupdown2 add-ons, which are add-on Python modules for each kind of interface configuration. And you can see these modules, they spit out commands in native tools language to configure network interface. Life of an iface object. So it's Python, and ifupdown used environment variables to pass on interface attributes to modules. ifupdown2 uses a Python object. So on the far left, you see the first block shows you an etc network interfaces file section, which is an iface object. And there you can see the iface object translated with each attributes. You can see some metadata. ifupdown2 discovers dependence of that particular iface object and passes the iface object is passed on to the modules, and the modules translate that to native Linux commands. how does ifupdown solve the network interface dependency order? ifupdown2, the main infrastructure package, queries individual modules for dependence. For example, a bridge port. The bridge module is queried for bridge port dependence. Bridge dependence, which are bridge ports. And it builds a dependency graph of all the interfaces in the etc network interfaces file. It sorts them and executes them in sorted order. And it provides options to query and execute interface configuration dependency order. There is an example in the next slide. So you can see on the right, there is that's a typical graph, typical configuration that we see. I'm not sure it's very clear, but at the top there is a bridge, and it has switch ports, VLAN devices on switch ports as the bridge ports, and there is a bond interface, and bond has slaves. And that gets translated into the sorted interface list at the bottom. Built-in devices support. This was specific, not a requirement, I would say. It was because our files had too many VLAN devices, and it was like thousands of VLAN devices, and having all the VLAN devices getting listed in the etc network interfaces file made it very large. So built-in devices support, in fine print it tells you the details. It basically, ifupdown2 can recognize VLAN devices when they appear as dependents of a bridge, and even physical interfaces, and it picks up those devices as it brings the bridge up. So this kind of reduced the interface size a lot. So this is just an example of the previous slide. Options to ifquery to query the dependents. There is a with depends option, there is a print dependency list, or you can print the dependency list in dot format and can translate that dot into a visual format using any GraphViz tool. Incremental changes. ifupdown2 queries running state of the interface before it applies the delta config. ifquery is extended to with options like running and check to check the applied state of the to compare the applied state against the persistent user supplied config. There is a new command, ifreload, which is similar to ifup -a, you can say, or similar to service networking restart, but it only executes up on interfaces that have changed. And the example there actually shows that you can use ifquery check option to check if a bridge interface, a running state of a bridge interface matches the user supplied configuration in the net interfaces file. And yeah, the check basically returns 0 or 1 depending on the running state. Here is an example of ifquery check. On the left side there is a bridge with ports, and you can say check tells you that the bridge is all fine. And on the right side, I remove a port from the bridge. It indicates that there is a missing port. And you can do an ifup, and ifup will apply the delta, that is, it will add the missing port to the bridge. And the next ifquery check command actually indicates that the bridge is fine. Templating. This was again necessary to reduce the file size. In our deployments, we have seen cookie cutter interface configurations for bridges especially. So ifupdown2 integrates an external templating agent called Mako. And Mako was a choice because it was used in our other projects at that time. But ifupdown2 provides easy options to plug any other template engine. So at the right side, there is an example of how we create 100 bridges by using Mako. And Mako is nothing but you can encode Python language into your etc network interfaces file. And you can use ifquery to render this template to see your expanded list of interfaces. So this reduces the file size to quite an extent. API, it supports JSON, both input and outputs in JSON format. You can provide an etc network interfaces as in JSON object format. And the examples actually show ifquery, there's a format option to print in JSON. So all the commands by default take native input and output, but there is a format option to input and output in JSON format. ifquery to persist running config. So since I had all the infrastructure to actually query the running state, this was an easy addition to the tool. What the example shows is you create a bridge using native commands and then use ifquery running to actually translate that running state into etc network interfaces format. And the last command actually cats that to etc network interfaces. Next steps, I'm looking at pushing ifupdown2 into the Debian repo, integrate ifupdown2 with systemd, and also work with network manager. We want to be close to Debian native as possible, and yeah. So then some more bug fixes and some more compatibility options. Maybe. So getting started with ifupdown2, it's already on GitHub, and there is a lot of documentation. There is developer documentation as well to add more modules to ifupdown. And there is a lot of Cumulus Linux documentation for ifupdown2. We have a ton of example files as well. And there is my email ID there. And that's about it, actually. Questions?
Hi. Yeah. So I'm relaying a question from IRC. There's people watching this over the world. And the question is if there's a reason not to replace the current ifupdown with ifupdown2.
Oh, there is. We would love to, actually. And
no, the question is if there's a reason not to do it.
Is ifupdown2 better? Is ifupdown better?
oh, you mean, yeah, actually my first slide, yeah, my first slide did contain some challenges. It is, we could not actually, sorry.
Well, perhaps if I can comment about the experience we've had with ifupdown in Ubuntu. There has been a delta for a large part, for a long period of time because of things like Network Manager, the manage true function that used to exist there. And one of the issues is that ifupdown is kind of hard to maintain if you're
yes.
Trying to do stuff and trying to change it. So at least making it in a language that's more easily approachable by people is a really great thing.
Yeah, that would have been my exact answer. It's in literate. It's
the question. Sorry, the question is if there's a reason not to replace the old one with the new one. So if there's something in the new one that you would say, okay, there's something that's not yet ready, or some cases that might not work.
Yeah, like I said, there are 2 or 3 things that are not supported. It only supports iNet and iNet 6 today, but if desktop environments need other families, it could be added very easily. But yeah, those things, if they're fixed, I don't see any reason why it can't be.
Maybe it's not exactly what you had in mind when asking the question, or they had in mind when asking the question, but I've heard a lot of talk that the systemd guys plan to have networkd, issuing the, no, seriously, issuing the syscalls directly for configuring interfaces rather than, shelling out to all of these external commands like IP, and that, maybe it's better if we just burn down the entire ifupdown thing entirely and just move over to using that. I wonder if you've been talking to the systemd maintainers about this.
I have looked at systemd. Right now, it still has the same problems. Like, I think you have to order your interfaces files, but those can be fixed, obviously.
But I wonder if you've talked to the systemd maintainers in Debian about this, because I think if your plan is to replace ifupdown with this, and their plan is to replace ifupdown with networkd, there's going to be a problem coming.
Sure. We are talking to...
So I think, we clearly understand that this is a conversation that needs to happen, and that's actually why we are here. And part of the problem is that the simple use case, in some sense, of a systemd style solution, still for our use case is going to not be complete. You still need a scriptable, templatable engine that will go on top. So where the breakdown happens and how the interfacing happens is something that we obviously are interested in making sure we arrive at a common answer to. We have I think it's fairly safe to say we have no vested interest in making this be the solution, but clearly, as was noted earlier, ifupdown was not cutting it for us. And this is our answer. If there's a better answer, that's okay, that's great. But the configurability and the templating is incredibly important because, on the desktop, you talk about 4 interfaces, maybe 6 VLANs, it's an interesting answer, or even on a server. On a switch with 4,000 VLANs, 16,000 VXLANs, and God knows how many ports coming in the next few generations, it becomes unmaintainable and unmanageable. And the thing that Roopa keeps talking about, the priority and ordering, keeping that in your head in 5 screenshots or 5, while it's scrolling by is impossible. It's guaranteed breakage. And that's a solution we have to have.
So a couple of things. One on the systemd network D stuff. My understanding that came up a little bit earlier in Debian Devel. There's been a little bit of discussion about that. My understanding is that is at present in development stage that I would call science experiment. There's something there. It can bring up a network, but it's not. It certainly doesn't do everything that the existing ifupdown does, let alone all the things that the enhanced one that you talked about today would do. I think that the future of the systemd network D stuff is probably more along the lines of if you have a system that is only going to have one static IP address with one static default route, you might want to just use systemd network D because it's about the simplest thing you can possibly run. And if you're in that situation, why have any complexity? But I don't think it has much desire to move higher in the stack. I think most of the systemd folks are using Network Manager to do anything that's particularly complicated, so I don't know that they were targeting the stuff that you're targeting with ifupdown2. And the other thing is, in terms of why not to replace the existing ifupdown with ifupdown2, the most common complaint that I have heard on that front is the fact that it's written in Python and ifupdown is a required package. So that would mean introducing at least some amount of Python into required, which is something that a lot of people have objected to in the past. There are folks who are already unhappy that we have Perl, big chunks of Perl in required, let alone adding a second interpreted language. Ubuntu already did that, I think, so they've already, so they crossed that bridge, but Debian has not, at least to date.
I have 2 questions, actually. I would like to know, first of all, if there's going to be complete compatibility to all the scripts, the ifup and ifdown hooks, because we use them a lot in Debian packages. And my second question is whether ifupdown2 has any plans to support dynamic changes, or because ifupdown doesn't do that, but for instance, if your DHCP gets you get a new address, as happens here at PSU, or if you go offline and so on, whether you're planning to hook into the netlink layer and react to it.
Yeah, I think today we already hook into ifplugd, and ifplugd can do most of the dynamic configuration using ifupdown. And your first question on ifupdown compatibility, yes, I think we will be able to do full compatibility.
I think it's very important
Yes,
that you do
yes.
Will this be packaged in time for the freeze?
The Jesse freeze. Well, today it's packaged as debs, and it's not in the Debian repo. So first we'll have to get it into the Debian repo. And yeah.
I think what he's saying is hurry up, if you want it in.
Oh, okay. Okay. Thanks.
I have a question more about how Cumulus uses this. Are users of your switches logging in and running these tools by hand, or are there, or have you designed this to allow there to be graphical or web-based front ends to do things?
They're usually logging in and running it, use the CLI, but there's also orchestration tools that we integrate with, like Chef. So there are a bunch of Cumulus guys, people sitting there, so they will definitely be able to.
Yeah, I mean, there are a bunch of different, if you have 1 or 2 switches, you're probably configuring this by hand by SSHing in and editing it. If you have, 1,000 switches, you're probably using either some homegrown orchestration tool or something like Chef or Puppet or Ansible or, what have you. Yeah, there's no, as far as I know, there's no web or graphical package. I mean, maybe Webmin has a module, but I'm not sure it's something that we, I think that reaction says it all right there. There's nothing stopping from anyone from writing that. And a lot of the tools, have configurable output formats, defaults to human readable, but you can get JSON formats or whatever. So if you're writing a tool like that, that would be a natural way to plug in.
So I think it's important, I suspect, our current use case is definitely high volume, lots of ports, lots of instances. If you are in the desktop or you're trying to make it simple for a laptop, which is where we wanted to even get to, there will need to be a graphical tool. I think that part we understand, and it's something we'll close. Well, yeah, but it has to find. Yeah.
Just don't make it Webmin. There's just something wrong about a network accessible network configuration tool, but maybe that's just me.
Couple questions. What's the contributor license agreement? What's the license, and what's the community like for ifupdown2?
Licensing questions to Nolan.
I've got a follow-up too.
Okay. There's no contributor licensing agreement. You own your changes. Obviously, we're more than happy to accept patches under the we went GPL on this one?
GPL.
Perfect.
GPL.
Okay, GPL v2.
Yeah, me too.
And the community right now is essentially, you're looking at it, but we're hoping to expand that, hoping to get more people interested and involved.
And are you guys running this on anything but Cumulus network switch gear running Cumulus Linux OS? Like you talk about wanting this to replace ifupdown. Have you tried it in servers?
We do run it on VMs, which runs it.
Yeah, I mean, we run it in VMs, and also our internal, one of our internal servers is actually running this as just a server. So, it's the overwhelming majority of it is currently used on switches, but it has, and I believe, Leslie?
Yeah, I've made sure it works on Ubuntu 14.04. So it works with no problem on that with 4 interfaces.
So I have another question from IRC. It's people that are really eager to test this, and they are asking if they can install it while they are running, and it will take over from the old one.
No, there are instructions on the GitHub documentation page. You have to, it conflicts with the ifupdown package, so you have to remove the ifupdown package and then install this.
Yeah, but can this be done live, or
Yes,
will
yeah.
network be down in the middle?
I think you can do it live.
It depends on the config, though, right?
Yeah. I have not tested that, but
If you purge ifupdown, the network stays up. So if you pick up from that, then that's fine.
Well, one thing that I thought might be interesting to know, you mentioned that the templating helps reducing the size of the actual interfaces file, but to what extent have you tested, like, let's say, to what extent have you stress tested the tool? Say, could you install 1 million interfaces, and what kind of time would it take to actually apply this kind of configuration?
Wouldn't say 1 million, but maybe 1,000, couple of thousand.
If you're talking about several thousand interfaces.
It'll bring down the.
If you're talking about several thousand interfaces, this will not be your slow point in the system.
Yeah, because-
You're going to end up with syscontrol and sysconfig becoming the slow drag while it does its linear walk through all interface names.
Yeah,
This will be done within like 1/10 of the time.
Yeah, we've seen a lot of bottlenecks in the other cases. Any other questions? Yeah. Yeah. Well, I need some help getting this into Debian, so I don't know whom to talk to, maybe.
Once volunteers.
Sure, I'll come and talk to you.
Matthew? You? Yeah, I might be interested. Well, that's cool. You guys should flock together after this session,
Okay,
and then
okay.
it's not that hard.
Okay.
All right, any other questions? I don't think that's the case, so thank you very much for
Thank
this
you.
presentation. You've seen...
Thank you.
There were a lot of questions. There's a lot of interest. I can tell you from personal experience that
Okay.
people want something else.
Okay.
So good luck.
Okay,
and,
thank you.
Join the community.
Thanks, everyone.
Thanks.